Other important things to cover for combinations is their properties. So first of all, keep in mind, by definition, n choose r is n factorial over n times r factorial times r factorial. That's choosing r items out of n items. So first of all, first property is that if you have n objects or items and you're choosing one of it, it's equivalent to n choose one, and it would just be n because you have n objects to choose from. If you are choosing n objects out of n objects, there is only one way to choose it because you have to take them all. So n choose n equals to 1. Earlier we covered with the example of the 2 red marbles and the 2 blue marbles, I mentioned this property. So if you're choosing r objects out of n objects in total, it is equivalent to choose the remaining n minus r objects out of n objects, and they are, because they're equivalent, so n choose r actually going to equal to n choose n minus r. And if you try to do the math, for example, we know that n choose r, to verify this result, we know is n factorial over n minus r factorial, then r factorial. That's the left-hand side. Right-hand side, we're just going to follow the definition closely. That is n factorial over, so we have to do n minus r. So it's n minus r factorial, and then n minus r factorial. And once you simplify it, you will see that it's r factorial n minus r factorial. So you can see that by applying the definition, we know that n choose r equals to n choose n minus r. The third property, which is pretty interesting here, is that if you are trying to choose r objects out of n objects, which is n choose r, it is equivalent to n minus 1 choose r plus n minus 1 choose r minus 1. And this is true if r is between 1 and n. Lastly, we're going to cover this binomial theorem. You probably have heard about this before in your other mathematics or statistics courses. And the theorem itself is saying that if I'm trying to find out what is a plus b raised to the power of n, what's the value of that, it will be equivalent to the right-hand side here. And now remember, this is our choose function, n choose k. So this notation is talking about the sum, okay? Sigma, it's big sigma, and it's summing all of the terms behind it. So if we expand this term, what this is saying is that, so notice that k goes from 0 to 1, that's changing. So it's equal to n choose 0, a to the power of 0, and then b to the power of n minus 0. That's the first term. That's when k equals to 0. And then you move to plus, because that's the sigma, the summation, n choose 1, a to the power of 1, and then b to the power of n minus 1. And you keep adding until you go to the last term. So last term here, when k equals to n, is n choose n, a to the power of n, and then b to the power of n minus n. So the binomial theorem can be proved by mathematical induction in the other courses we talked before, and can be also proved by the combinatorial consideration. So this is what we are talking about here. And for each of the term, let's just look at the first term really quick here. Because a plus b raised to the power of n in total. So each of the term of the sum here going to be a combination of a and b, and in particular, a combination of a and b in terms of their powers. So when you have k, which is indicating the power of a, then the other term about b will have n minus k power. So that's why you have this term after the choose function. The choose function is needed here because we need to determine how many possibilities you're able to get a to the power of 0 and b to the power of n minus 0. And it's going to be choosing 0 out of n. So it's going to be an n choose 0 choose function in front of it. And here we included an example of thinking about the license plates that we did before. And in particular, that if we have license plates that form by n digits, and each digit can be either a letter or a number, which is equivalent to a equals to 26 and b equals to 10. So this is an extension of the example that we saw before. And the total number of distinct plates that you can come up with will be a plus b to the power of n. And we list all of the combination here. Capital NK is the number of distinct plates that contains exactly k number of letters. Okay, so again, k related to a equals to 26 because it's talking about the letters. So n minus k will be related to b equals to 10 because that will be the remaining choices for the numbers from 0 to 10, 0 to 9. Lastly, this will be what each NK is about. We have k letters, n minus k digits or numbers, I should say. And then because you can have duplicated letters or numbers for each of the digit of the license plate. So you have n to the power of k, which is based on the generalized rule of counting. And then b to the power of n minus k. And don't forget that you have this choose function in front of it because you need to know how many ways that you can have k letters and then n minus k numbers.